My name is Markus Kahelin. Warmly welcome to the G-Connect webinar series. We will be talking about networked audio today, covering some of the basics. What are we talking about when we say networked audio or IP audio? And then also a few words about what we have from Genelec to offer into that. And the focus will be on AV installations on this kind of general purpose audio-visual systems, and not so specifically about studio monitoring, which is the heritage and core of the Genelec offering. But today we'll be focusing on the AV installation part. And as mentioned, leave your questions. I'll stop every now and then, and also my back office will be checking the questions as we go. And let's start by looking at the very basic questions about networked audio. What is it? Why does it matter? What makes networked audio such a game changer and big thing in terms of designing and using AV installations and audio systems? And also, what is the offering, or what Genelec has to offer that we can provide for you? Let me just here switch my screen configuration a little bit so I can see you guys better. Now we are closing the 100 people mark already, so welcome on board. My name is Markus, and here we go about the network audio. And let's start with the very basics. What does it mean when we say IP and IP audio? The basic definition from Wikipedia is very long and fairly thorough, showing that IP stands for Internet Protocol, and that's a principal communications protocol in the suite of Internet protocols, which then is relaying datagrams across network boundaries. Routing functions enable networking, and essentially this establishes the Internet. Quite complicated explanation. I will try to give you a little bit more basic one as we go, but the important thing to note here is that we have protocols that we are using to pass information across a network, and this establishes or provides us a connection that we can use to pass different kind of information on the network. Starting with the network definitions, let's look at what is a wide area network. And streaming audio across a wide area network is something we could call internet audio. It is something that usually happens on a user demand. You click on a service, and then you press the play button and you start receiving some media. This means also that it is requiring some buffering, because the audio or signal that we are receiving can be coming from very far away. It may be on the other side of the globe on a cloud-based server. So this is not enabling us to have real-time traffic and real-time signal transmission. Services like Netflix, YouTube, Spotify have this kind of online streaming service available, and a very similar application is the use for teleconferencing, like we are doing today. Skype, Teams, different webinar platforms are using the same kind of application to pass audio and video over a wide area network across the globe. And these services over the wide area network can be accessed over a wireless connection, a VLAN, where you can connect your device, computer or smartphone on a wireless network. And because these services are relying on buffering, it is not real time. It is also easy to arrange this kind of connection over a wireless network. But if we want to use real-time audio on a network, we have to do it on a local area network, LAN. And streaming on a local area network is enabling us to do real-time signal transmission. And that happens over a local network. It is traffic between devices on that local network, and it's based on a subscription. The devices shake hands, and some device is sending and another device is receiving, or multiple devices are receiving. Because it's on a local network, it can be used for real-time applications like a microphone feed that needs to be in sync with the real life. And this is to do with the latency performance, how quickly the signal can be passed through the network. And on a local area network streaming, you can have a performance with as low latency as 1 millisecond or few milliseconds. Because of this low latency requirement, the network connectivity needs to be with a wire. So the devices need to be plugged in through the Ethernet port and establish the network connection that way, which is a faster way to connect the device to the network and provides a low latency, low buffering connection. So local area network for normal applications like we use every day can look like something like this, which is a local area network for office application. You have different devices, computers, telephones, printers, scanners that are connected together, and you have few switches that are forming the network. So this way we can have the network running services for different devices. Then you can also patch connections to the local network through a Wi-Fi router. You can have wireless connections from mobile devices. You can connect servers onto that network, or you can have access to the internet through your network infrastructure. But by default, the local area network itself does not contain the internet connection. That is just one additional service that can be added on the network. So we are talking about a network that is within one building or a block of buildings and not spanning across the globe. And inside this local network, we can then use also real-time audio applications. So we can convert the network that is normally used for this kind of everyday communications and start using that same network infrastructure for audio. So we form a so-called local audio network. This is my own terminology, which I have invented, so it doesn't connect to any specific documented network infrastructure, but I think it's a good way of describing how local area network can be used for local audio transmission. So basically, the network is replacing our signal cabling. That's the idea. We pass audio into the network and it travels through and then comes out at the other end or at the other connection point of the network. And the network itself has no directions. It's bidirectional traffic, so you can have inputs and outputs in a very similar way. You don't have to worry about the connectors and the type of connector. Can we use it for input and output? Like in analog audio or digital audio, you have to have the correct connector to have it as input or output, or then you need to patch it or convert it. And the network has a lot of capability to transmit these signals, so we can use it also for multi-channel connectivity. We can replace our multi-channel signal cables and snakes and use the network to pass a lot of channels from different parts of the network across to the other parts. And those of you who have just joined, welcome to the G-Connect webinar. We are talking about networked audio, and my name is Markus. Welcome on board. This is the Genelec G-Connect webinar series. If you have any questions or comments, feel free to drop them in through the webinar platform, and also you can find some handout material through there. And now we'll be talking about a little bit about the different features and benefits, why networked audio and using local area networking is a good idea for forming a audio system. First one is the cabling. Network cabling is very cost effective. It's using standardized industry standard Cat5, Cat5e, Cat6 type of cabling that is easily available all around the world from many different manufacturers. The cables and the connectors are not audio specific. They are your normal everyday Ethernet port RJ45 connectors, which are also very cost efficient and easily available, and also installing the connectors is a standardized method. You have very good tools and a lot of different connector options available. Then thinking from the designer's seat, when you design the cabling for the system, the routing of the cabling, where actually the physical cables start and end, does not determine your signal chain. You don't have to know exactly what kind of channel counts you need to transmit from which room to which room, and as long as you can provide a connection point to the network, that's your signal chain. Every endpoint can be a multi-channel connectivity point. You don't need to have multi-channel connectors and big patch bays or cable snakes, as long as you have a network port available. And also everything is in and out. The traffic on the network is bidirectional, so wherever you have the connection, you can send or receive signals from that point. Then looking at the signals, we are talking about professional uncompressed digital audio transmission, which is the same quality as AES EBU signals. It is multi-channel, as mentioned, bidirectional, so in and out on every point, depending on the devices that we are using to connect to. The cabling itself doesn't apply or infect the signal. It doesn't apply any noise. So the immunity for different interferences is very good. By default, this kind of network cabling can be 100 meters long, or you can even extend that by using optic fibers between switches. So the typical limitations of cabling lengths are easily overcome with this kind of network cabling. Also, the network itself is very easy to design. You can do any scale or any size of a system, and these network devices, switches, are easily available, and also you have design tools and practices available how to design and model and scale a network. And the hardware that the network is using is not audio specific hardware. It is your general purpose network hardware, switches and routers available from many different brands, small scale, larger scale, unmanaged or managed. And also one additional feature of these switches, which is also something we are using from Genelec, is the fact that you can use it to feed power through the network cabling with this power over Ethernet Plus standard. So easy scalability, and then thinking of the system level, you can very easily integrate devices from various brands together. The signal streaming formats or the streaming protocols are standard and open. AES67 ST2110 are standardized and widely available, and also Ordinate Dante streaming format has been adopted by many different manufacturers and is available for different kinds of devices, starting from mixing consoles, simple signal converters, different kinds of routing matrix devices, and microphone systems, and also loudspeaker systems. The system scalability is very easy and very linear. You can add or remove devices, and also the scalability, the cost of scalability is very linear. You can easily just purchase few more devices, connect them, and the system will then grow if needed. It's very easy and flexible to implement changes, add and remove devices, or change the purpose of a certain room or a certain part of the building. And the same system can be used also for video transmission and different kinds of control features. And on many devices, these are also integrated together. Then we have different management tools available. There are software tools that enable discovering devices on the system, monitoring them. Are they online? How are they doing? Assigning and routing the signal can be done with software tools. You don't need to go and physically patch cables to change your audio routing, as in the analog domain would happen. And all of these devices have the ability to be integrated into control and automation systems if the device manufacturer has given the appropriate interface for programming this functionality, but the hardware connections are integrated together. The management and device discovery and signal routing can also be done over a wireless network. The management part doesn't contain the streamed audio, so you can easily manage and control the system also wirelessly, walk around the building with the mobile device and do the needed actions. But the signal streaming itself needs to be running on a cable. So these networked audio systems are also used for various different applications. The technologies are not application specific. You can use it for background music, different kinds of AV applications, corporate AV, different kinds of multimedia, educational facilities, live events and live venues, for pure entertainment, academic research systems where you need very complex and high channel count playback systems. And any scale or any size is easily available and easily doable. And we have a few case studies already available. Those you can also find on the handouts of this session, so feel free to check them out. They are also available as links and online on the genelec.com. So featuring a few real-life examples of the use of networked audio, the Finnish Music Hall of Fame just recently opened music museum is using in the exhibition different kinds of network systems, and including audio systems and Genelec loudspeakers as part of that. Then we also have another museum, which is a fantastic venue, Mosgard Museum in Denmark. The building itself already is stunning when you see it from the outside with the landscape, and inside you have a very well put together different kind of exhibitions, and it's a multi-purpose facility with different kinds of rooms, halls, virtual reality, and so on. So those are all equipped with networked audio system and systems, and also Genelec loudspeakers. Also, we have the links to these case studies in the platform available. And then the last one is G Live Lab from Finland. It's a live music venue that is currently operating in 2 different cities, featuring very sophisticated and multi-purpose audio systems used for anything spanning from rock to jazz, contemporary, classical music, folk music, and electronic music. And they have a electroacoustic system that is using the network audio along with a lot of different connections within the building and also to broadcast systems. So those are the different fields of application and few examples of what networked audio and IP audio can do. And then let's look at what Genelec has to offer, what kind of products we have recently introduced for the AV installation market. We call it Genelec Smart IP. It is a system where audio, system management, and power is passed in the IP network, and all that on a single cable. The products themselves are compact active loudspeakers that have a very flexible way of adapting to the room acoustics, versatile management systems, and status monitoring over the IP network. You connect them through a single standard CAT cable, Cat5e or better, and the loudspeaker system is also powered through the network cabling using PoE, Power over Ethernet Plus, or even PoE, lower voltage network-based power management. We have tools for the system management, also open API application programming interface that can be used to control this loudspeaker system from a third-party control system. And we provide support for these mentioned streaming formats, ST2110, AES67, and Dante. Any of these can be used. These loudspeakers also feature an analog line-in connector to be compliant with local source. If you have a microphone system that is not networked, you can also patch that in through the conventional cable as a little bonus on this system. Just to highlight some of the frequently asked questions about the Smart IP platform and the loudspeakers. Smart IP is not a studio monitoring system. It is not intended to be used in a studio monitoring application. It's not IP67, which would stand for waterproof mechanics. And it is a general purpose AV install system, which you can use for all of these different applications that we already touched upon. Installed audio system, if we focus on the audio side only, in the conventional way, when you construct a system, you have different devices, AV automation and control systems, audio processing hardware, routing matrices, audio amplifiers, voltage line drivers for 100-volt lines, and so on. And we at Genelec like to think that all of this functionality and much more can be integrated into the loudspeaker itself. So active loudspeaker design enables us to build inside the loudspeaker power amplifiers, equalizers, level and delay trimming tools, memory slots to recall different situation memories, links to the automation system, status monitoring, and the audio streaming or signal receiving functionality. And all of that is featured in the Smart IP 4420 and 4430 loudspeaker systems. These loudspeakers are powered through the network, and the network switch needs to be equipped with PoE Plus Power over Ethernet functionality that is driving the needed low voltage power into the loudspeakers along with the network traffic and the streamed audio. Maximum cabling length also in this scenario is 100 meters, and the switch that you are using is from any manufacturer that has the standardized PoE Plus available on the network ports. And this means that your cabling is also reduced. You don't need to run mains power 230 volts in Europe across the system. You can just feed the mains power into the network switch wherever that is located, and then feed with low voltage lines the power for the loudspeakers. And this is also one of the cost-effective features of this kind of system. If you have an existing building that has network switches already in place and installed, but they don't feature any PoE plus power, then you can use additional piece of hardware called PoE Plus injector, which you connect in between the switch and the loudspeaker, and this PoE Plus injector is then acting as your power supply and feeding the power into the loudspeakers. And this enables you to use the existing network hardware in a building where you already have the network in place, and you don't need to replace all of the switches, which usually is one of the more expensive parts of the network infrastructure. Each loudspeaker requires 30 watts of power from the switch. The power on the PoE Plus is a IEEE standard, and delivering 30 watts out of the port on the switch. At the receiving end at the device, if the cabling is long, you get a little bit of power loss and you receive 25 watts roughly at the loudspeaker end. And we recommend this PoE Plus 30 watt power to be used with these loudspeakers. They can operate also with the conventional older IEEE standard PoE that is 15 watts, but that is something that is not recommended or the default scenario. So you need to have 30 watts of PoE budget on your switch to power one smart IP loudspeaker, and then as many loudspeakers as you want to connect, you need to make sure that the switch is capable of providing multiplies of 30 watts of power through that. The switches have very clever power management using LLDP, link layer discovery protocol, that is power managing the ports, also providing overload protection and different kinds of fail-safe mechanisms. So this is also a very reliable and safe way to power the loudspeaker system. There is also a lot of engineering behind the power supply design of these systems, since we receive from the network a fairly low amount of electric power. So we have designed a power supply that has a energy storage inside the loudspeaker, and the network feed of power over Ethernet is used to charge or store the energy inside the power supply, which then can be used to power the amplifiers and providing more peak power when the loudspeaker needs to be capable of providing higher peaks in a dynamic audio signal. And this way we can get more dynamics out of the system as you would with let's say more basic power supply design. Network topology is exactly the same for these as any other network connected device. So a star configuration, each loudspeaker is receiving its own cable and own network connection from the ports of the switch, along with the PoE plus power. And if you have a larger system, then you can connect multiple star configurations together, connected to a central switch or a router in a larger system. and this way you can scale the system to any number you need to have. Channel count is one very popular question about the network audio systems. How many channels can it do, and what kind of quality level can it achieve? And here's a little map of that. So depending on your streaming format, which you are using to send the stream to the network, AES67 ST2110 can do sample rates up to 48 kilohertz, so matching quality as the basic AES EBU digital audio. And the stream is constructed out of 8-channel streams, which are then combined together to achieve the needed channel count, the total channel count. Whereas on a Dante streaming, the maximum sample rate is 96 kilohertz, and the Dante stream is constructed out of 4-channel flows, which are connected together. And this way, the sending device can send a large number of channels by combining these 8-channel or 4-channel streams and flows together. These two different formats cannot coexist on the same device at the same time. AES67 ST2110 or Dante needs to be selected when you configure the device, which one you will be using. The loudspeakers in the Smart IP platform can receive either one, but you need to make the configuration at the beginning because these two formats, streaming formats, are using different version of the PTP precision time protocol synchronization, which is your signal clocking across the network. And that is one of the reasons why they cannot coexist on the same port of a single device. They can coexist in the same network, but you have to decide which one you will be sending or receiving. But this means that the streaming device, the source for the signal into the network, can have a lot of channels, easily 24 or 64 or 128 channels even, from a single network port. And then the channel count of the playback system has no limitation. You can have as many loudspeakers as you like, providing the fact that you carefully design the network to cope with the resulting traffic, and you have enough power feed from the PoE plus capable switches. So this is, in short, what kind of approach we have from Genelec towards network audio for the AV install market. And the Smart IP systems are available. More information you can find online, and also feel free to send in your questions or comments through the webinar platform here today as we speak. I like to thank you all for taking the time to join us today. Stay safe wherever you are. You can see that we are currently located away from the factory. I'm sitting here in my downstairs bedroom, sharing these views with you. And the Genelec factory and headquarters is about 2 kilometers that way, operating in a little bit extra security, but in normal operations. And our people are all available online. Genelec support is open. Genelec social media is active. You can interact with us through those channels, and also stay tuned for the future episodes of the G-Connect webinar series. We will be featuring more different topics through the coming weeks and months, and me and my colleagues will be happy to share our views on the different aspects of the interesting audio world, which currently is also very heavily network based because we cannot travel and meet each other, but hope to see you also in real life one day somewhere around the world.